Right, now we will see the transient response in case of series RC circuit for step input. Okay, since it is RC circuit, it is a first order circuit. Again here we can use the standard solution of homogeneous equation, right? So what is that? It is again dy by dt plus p y equals to q. So we are going to directly compare our differential equation of the circuit with that standard generalized differential equation to directly write the solution. So we don't need to use complementary function and everything. The time domain differential equation solving we don't need to have here, because we have a direct formula for this kind of equations. Okay, fine. So what is the circuit here? Step input voltage of value capital V, and there is a switch in between which is coming down. That means it is getting closed at t is equal to 0 seconds, and then it is connected to the RC series circuit. So again at time t greater than or equals to 0, switch will be acting as a closed circuit, that means short circuit, and we will get one loop here. Again we are going to apply KVL. So what is the KVL equation? It is minus V plus R into I of t plus Vc is equal to 0. And we all know IC of t is equal to C into dVc by dt, right? So when you use that and integrate on both sides, you will be getting Vc of t is equal to 1 by C integral IC of t dt. Okay, now let us substitute this equation number 2 in 1. So you will be getting minus V plus R into I of t plus 1 by C integral IC of t dt equals to 0. So for solving the time response for any given circuit, we need differential equation. But what we have got here? Here we got one integral term. So how we can avoid this integral term? So we have to go for differentiation on both sides now. Okay, so when you do that, you will be getting what is the differentiation of capital V? It is a constant, so it is 0. Then R into I of t becomes R into di by dt plus 1 by C integral IC of t dt becomes 1 by C I of t, because integral and differentiation will be cancelled out, right? Okay, now finally we will be getting an equation like this after further simplification. So now again what you can do, you can easily compare that with this particular standard equation, dy by dt plus py is equal to q. So if the independent variable is x, then it will be dy by dx, but here our independent variable is time, because we are doing time domain analysis. So that will be d by dt, right? So again we have the formula. What is that? Y into integrating factor is equal to integral q into integrating factor dt plus k. So it is same as that of the one which we have used here, only we are considering it as integrating factor. I hope you know it, right? The same thing you can even use here with a different terminology. We are saying it here. Okay, now what is integrating factor? It is e power integral p dt. So what is p? P is 1 by RC. And what is q? Q is 0. So it is very easy to work out this because of this 0. And then when you solve this, you will be getting an equation in terms of the constant k. So again, how to get constant k? Using the initial conditions. So but generally for capacitor, the initial conditions will be given with respect to voltage, because we all know that the voltage across the capacitor is not going to change very suddenly. That's why the initial condition is with respect to voltage in case of capacitor. In generally that is given. So with that condition only we are choosing Vc of 0 is equal to 0 volts here, but not I of 0 is equal to 0. which was the case of inductor. So here the initial condition is with respect to voltage because it is RC circuit. Okay, right. Now let us assume Vc of 0 is equal to 0 volts. And very important point here, if Vc of 0 is given already in the problem, you have to consider that. Since it is not given, we are assuming this value. So even in the exams you clearly specify it is assumed, right? And if there is a possibility to determine also, we will be determining. Okay, right. So now since Vc of 0 is equal to 0 volts and this is at 0 time t is equal to 0, let us draw the circuit at time t is equal to 0. So at time t is equal to 0, the switch is already closed, so it is replaced with short circuit. And very important point is that the Vc is also got short circuited here because the initial condition we have considered as 0 volts. Very important point. Now for this you determine I of 0. So what will be I of 0? I of 0 is nothing but V by R now. And since we have I of t equation here in terms of k, just to replace t is equal to 0, then what happens here? I of 0 will be equal to k into e power minus 0. So this I am using here, right? So from this what do you get? K is equal to V by R. So this is how we are going to determine the constant unknown k value. So then what you do? You are going to substitute this in our expression that we got after solving the differential equation, right? Okay, so you clearly specify the time condition because we have got this KVL equation for time t greater than or equals to 0 only. So you should clearly mention that also in the final expression. I of t is equal to this expression only from t greater than or equals to 0 onwards, right? Okay, so suppose in the same question if voltage across the resistor is asked. So what is voltage across the resistor? VR of t, it will be I of t into R. Okay, since we have already got I of t, you just need to multiply with R. Then what you will get? You will get V into e power minus t by RC. Similarly, you can even get Vc of t, which is equal to 1 by c integral 0 to t Ic of t dt. So when you solve it, you will be getting this. I hope you will be practicing this. Okay, so now let us plot the response of voltage in case of series RC circuit. Okay, or otherwise current, anything you can plot. Here we have shown the plot of I of t, which is exponentially falling down. And if you have observed in case of RL circuit, the response of current is exponentially increasing. Okay, in case of RC circuit, the current is exponentially coming down. Okay, it is very important point. So here in case of capacitor, the time constant is defined as time taken for the response to reach 0.362 times that of initial current. Okay, because it is falling down, it is defined in different way. So in the same manner you can derive this also, the time constant, because at time constant tau, as per the definition, the current should come to 0.362 times of initial current, and initial current is V by R here. We already got initial current. What is that? I of 0 is equal to V by R. So accordingly you can derive I of tau, which becomes equal to RC in case of series RC circuit. Okay, so this RC can be replaced with tau as given here. Fine. So this is all about series RC circuit when excited by step input or DC. Thank you.